Uh, so, hello everyone. My name is and Jamil, and I'm a student of IITM BSc degree. I'm currently in diploma level, and apart from this, I'm also a third year IT student at NIT Srinagar. So today I'm going to talk about cryptography in practice. So I'll first briefly introduce about what I'm going to say. Then I'll share then I'll talk about some cryptographic algorithms. And at the end, if you have any questions, you may ask. So we all use cryptography in our daily lives. When we send a message on WhatsApp, it is end-to-end encrypted. What does it mean to have for a message to be end-to-end encrypted? Well, it means that the third party or anyone sniffing the conversation will not be able to read what we are sending. So in WhatsApp, we use AES encryption. It is a type of symmetric encryption. Similarly, when we browse an HTTPS enabled website, what does it mean that for a website to be HTTPS enabled? It means that it has a certificate which ensures that the domain it is claiming to be, it is actually that domain. In our browsers, we have some certificates pre-installed that we trust, and any of those certificates, if it validates some other certificate, we are also trusting those certificates as well. And we use cryptography in online transactions and two-factor authentication apps, in password protected Wi-Fi networks. When we input a passcode in our, let's say, PC or mobile, encryption we use, everywhere. So now let's look at some cryptographic algorithms. First of all, let's talk about hashing. So what is hashing? Well, hashing, simply put, it is a function that takes arbitrary data of arbitrary size and maps it to some fixed values. For example, we may give it a string, let's say your name, and it will output a string, a binary string of, let's say, some bits. And we can also give input to it, let's say 1 GB file. It will again give some other uh, fixed bit string. So typical example is SHA-256. It is widely used hashing algorithm. We can give any input to it, and it outputs a 256-bit binary string. Where can we use hashing? Well, we do not usually store passwords as plain text in our databases. We can use hashing for hashing there. We can, instead of storing plain text passwords, we can use hashing and store the hashes of the passwords. Uh, where can we use hashing other than that? Well, if you are downloading a file, you may have seen that we have some hashes on the download pages that are given. Well, after downloading the file, let's say 1 GB file or 10 GB file, you can calculate the hash of that file locally. And if the hash is or same, then you are pretty sure that the file you are intending to download is the same file you have downloaded. So let's talk about symmetric encryption. Like I gave you the example of WhatsApp, it uses AES encryption. In AES encryption or symmetric encryption in general, we use same key for encryption as well as decryption. But for AES encryption or in general symmetric encryption to work, you should have same secret key and shared key, which must be secret. Otherwise, if any other party has access to that secret key, they will sniff your conversation. So how can we reach a shared secret? Well, we'll look at it in a minute. Then we move on to asymmetric cryptography. Unlike symmetric cryptography, here we use two keys. We have a key pair, a public key and a private key. Well, we use public key to encrypt the data, and only the one who has access to private key can decrypt the data. Well, where can we use it? Well, in Bitcoin, you have an account and you have a public address and a private key. Anyone can send Bitcoin to you using your public address. But if you want to send Bitcoin from your account to some other account, you need that private key. and only using that private key can you send Bitcoin from your account to some other account. Now let's move on to signing. So in signing, we also have two keys, private key and public key. Here we use private key to authenticate some digital data, and we can use public key to verify that data. Actually, uh, digital data can be altered, or we can change it. That's why it is important for some critical data to be authenticated. In when we use HTTPS websites, we also use signing there, because in our browsers we have some certificates that we trust. They are when we install our browsers, they are there, and any certificate signed by those certificate providers, we our browser automatically trusts those as well. And if there is some certificate which is not trusted by our browser, then it shows some alert that this we cannot establish that this is a valid certificate. So let's move on to key exchange. Well, I told you about for AES or symmetric encryption to work in general, you need to agree upon a shared secret. So if you are communicating using an insecure channel, you need some kind of protocol to exchange key, and you can use Diffie-Hellman to exchange key. It guarantees that anyone listening to your or sniffing your conversation will not be able to get anything about any information about the secret you are agreeing upon. Uh, so, key derivation. Let's suppose you wanna encrypt your hard disk using AES encryption. Well, obviously won't be remembering the 256-bit long binary string. So instead, what you could do is you encrypt it with the password, pass that password through some key derivation function. It returns a key, and then use that key to encrypt the data. And next time when you want to decrypt the data, again pass the same password through some key derivation function. It will again generate the same key and use that key to decrypt the data. Now, password storage. Well, I told you about we can use hashing to store passwords in a database, but hashing functions are not built for those kind of operations. Well, it is practically possible to brute force the passwords that are stored using hashing. So we use something called password storage algorithms. A typical example is Cycrypt. Well, here you have a function that is intentionally made computationally intensive. That means it makes brute forcing practically impossible. So in data, if you want to store passwords in database, you should use any mainstream password storage algorithm like Cycrypt. So now moving on to authentication codes. What are authentication codes? Well, you must have seen two-factor authentication codes that are used for in most of the websites these days. Well, there are mainly two types of authentication codes, TOTP and HOTP. TOTP is actually time-based one-time passwords. It generates time-based one-time passwords, and HOTP it generates count-based one-time passwords. So what TOTP generates is will depend on time. For example, you may have a time slice of 30 seconds. So after every 30 seconds, it generates a new password. So you can use it in your website and see will does the OTP provided by the user match the current uh, valid OTP. So if it matches, you can allow the user to log in. And if it doesn't, you can just say wrong OTP. HOTP is similar, but it is count based. For example, first time you use, you have one, but second time you log in, you have a different OTP. So I think that's it. If you have any questions, you may please ask. Deepak is saying how to generate OTPs. Actually, I have a repository, GitHub repository link here. You can use it. I have codes for all the algorithms. You can check it there. It is written in Python.
Okay, any other questions? Okay, thank you, Jamil, for this talk.